Welcome back. In this video, we will start talking about preferences. Preferences is just about liking, and I had already given you example that when offered tea or coffee, whether you would like to get tea or coffee, that depends on your liking. We are going to talk about these likings in a very systematic manner. We will have some basic assumption, and one basic assumption is that your likings or preferences would not change for the decision period. That is a wrong assumption if decision period is an extended period, but if you are making decision in short period, then it is an okay assumption to make, and it's largely true. So let us start with our assumptions. The idea is very simple, that we are trying to give mathematical formulation of decision making. So decision maker should have certain attributes satisfied, like if we are talking about moving car in physics or mechanical engineering, then of course they would satisfy Newton's law of motion and gravitation law and things like that. We do not have laws, but we need those kind of assumption to talk about decision making in systematic manner. So first two assumptions are called rationality assumptions, and the first one is completeness and second one is transitivity. So let us look at them one by one. So let us begin with our conjunction possibility set, and that we are representing using capital X. Conjunction possibility set can also be called just conjunction set. You may wonder why we are not involving ourselves with conjunction feasibility set or the budget set. The problem is that budget set may change over time, and then we have to, every time we have to begin with basic. Therefore, we want our likings to be defined on conjunction set. Anyway, when it comes to likings, it's hardwired in our mind that we like certain things, we dislike certain things, and it doesn't matter what we have in our pocket, whether we can afford that particular bundle or not. I may not have fancy cars, but I can say that I like this fancy car more than some other fancy car, and so on. So therefore, our preferences would be defined on the conjunction possibility set. And the first rationality assumption is of completeness. The idea is very simple, that if we take any two bundles in conjunction set, and of course it can be n tuple if in this world we consume n different items, or it can be an ordered pair if we are living in a simple Robinson Crusoe world of coconut and fish. So it doesn't matter, we can take, we are just using x and y to represent them, and we can say that for any x and y we have in capital X, one of these should be true, that x is preferred to y, and this has a symbol that x is preferred to y is a shortcut way of writing. Second, that y is preferred to x, and the third is that you are indifferent between x and y, and indifference has this symbol. So whenever we take any two bundles from conjunction set, we are able to say either x is preferred to y or y is preferred to x, or you have evaluated both of them and you figured out that you are indifferent between x and y. So two inherent assumption here is that you are not ignorant, that you cannot compare x and y, and also inherent assumption is that you are able to decide, which may not true for us in real life. Many times we are simply not able to decide, but this assumption will preclude such situation. The idea is that you should be able to decide all the time, and that's happen eventually. If the decision is really important, you will study, search it on Google, read it on Wikipedia, or you will try to figure out, and ultimately you will try to reach a conclusion that whether x is better for you or y is better for you, or you are indifferent between the two. So that's what completeness is all about. It ignores ignorance and it says that you are able to decide. Next one is transitivity. What is transitivity? Now we need to take three bundles x, y and z, and they are all three different bundles in conjunction set. What we say that if x is at least as good as y, first let us understand that what is at least as good as. At least as good as has a symbol this. So, it combines preferred to and indifferent. So, if I go back and say these three things can be represented by two different things, one is x is at least as good as y or y is at least as good as x. What is the difference? That these three are mutually exclusive. Okay? Here we are combining first one and third one here and second one and third one here. So, these two are not mutually exclusive. It is possible that when I say mutually exclusive, what do I mean? That it is possible that this is true and this is true. When will it happen? When x, you are indifferent between x and y. So, we can say x is at least as good as y and y is also at least as good as x. So, this would be true. In that sense, it is not mutually exclusive. So, the symbol for at least as good as, that the combination of these two. So, we say that x is at least as good as y and y is at least as good as z. It implies that x is at least as good as z, and this is true for all x, y and z in x. Let me tell you, this may not be true in reality. Let us take three bundles, and in this bundle Robinson Crusoe has access to three kind of fruits: mango, guava and banana, and we can take a bundle. So, first number is for mango, second number is for guava, third number is for banana. We can take three bundles. What it means? This person has one mango here, one guava here, one banana here. It is very much, in short, we can also denote it by bundle M, bundle G and bundle B. It is very much possible that this person prefers mango to guava, guava to banana, but banana to mango. So, he has circular kind of preference. You can start with mango, go to guava, go to banana and come back to mango. It is not here, transitivity is not satisfied. And in this case, a person can end up selecting either mango or guava or banana. Let us say first he is given guava and banana, he will pick guava, and then he is given guava and mango and he will pick mango. So, selection is of mango. We can get anything selected, even banana can get selected. Let us say this person is given first, if we want banana to be selected, we can start with mango and guava. This person will select mango, and then mango and banana, this person will select banana. So, anything and everything can happen because consistency is violated. So, transitivity is simply about consistency. That is what it is all about. And we say a person whose liking satisfies completeness and transitivity, that person is rational in decision making. By the way, please understand, no way I am saying that we all are rational in our life. We may not be. We are not like machines that we behave in a similar manner and we follow certain laws. We don't. We take irrational decision. But if we allow humans to be irrational in our model, anything and everything can be justified on the basis of that this person is like this, this is what he or she does. And this explanation does not have any bite, we do not learn anything about the person. So, that is why we say that we will assume that people are rational all the time. What it does, it helps us in business decision, that if something is going wrong, we will try to fix our mechanism rather than fixing people. Anyway, that's not in our control, and so it's good idea to fix human behavior in a particular manner and think about the his or her behavior in given system. So that's what assumption is. I just want to say, let us say you have a finite number of bundle, and so what this rationality assumption would do, that you would be able to rank them in some order. So let us say, how can we rank them? If you take x and y, either x is preferred to y or y is preferred to x, and you are indifferent. So let us say y is preferred to x, so we can write it in this order. Now you can take z and y. What is the possibility? Either z is preferred to y, so then z will go here, or another possibility is that x is preferred to z, so z will go here, or another possibility is that y is preferred to z, but z is preferred to x, so z can come here. So let it be here, and then we will take w and we will start comparing with x, and it so happens that x is preferred to w because that's allowed, and then we take v and we can figure out that w and v you are indifferent to. So now we get the order that y is most preferred, then z is preferred, then x, and then w and v. You are always able to rank the finite number of bundle, so ordering will be complete. And then I am saying getting ahead of myself, but let us say that only these are feasible given your income, then of course you will choose Z because that is the most preferred one. So it really helps us in understanding the decision making. Okay, we are able to rank all the bundles in the consumption set. But one problem you should understand, you are all mathematically inclined, you should understand that this ranking has worked well for finite number of bundles in set X. But in real life, because if we allow for convexity, then the bundles are really infinite in nature. So when bundles are infinite in nature, and let us say we have two-dimensional world, so we have a really large number of bundles, and when we are ranking them, we are putting them on in one dimension and we are ordering them in one dimension. Sometime it may be feasible, sometime it may not be feasible, but we want this feasible all the time, then we need another mathematical assumption, and that is of continuity. So before we proceed further with continuity assumption, one thing we should understand that what rationality assumption does to consumption set. It helps us rank any two bundle in the consumption set. We take any two bundle x and y in the consumption set, we should be able to put x at a higher level, higher rank than y, or y higher rank than x, or at the same level, any two such bundles we take. So what we can say, rather than dealing with in terms of x and y, we can assign a number. If this is the situation, x is better than y for you, assign a higher number to x and lower number to y, and you can compare 10 to 8. Because 10 is higher than 8, of course the x is preferred to y because a higher number is associated. So we can restate our problem in case of multi-dimension, that when we are arranging the bundles in one dimension, we have only real numbers that can be given. If we do not have enough real numbers to give to all the bundles, because consumption set is in higher dimension, then we would require perhaps more assumption, and that's what continuity is doing. So we have here, let us say, 3 bundle x, y and z. So it should so happen that the number assigned to y vis-a-vis the number assigned to x, they should be closer to one another in comparison to x and z number. So let us say if it is 10 and it is 20, because y is closer to x, it should have a number associated between 10 and 20 to 8, and that's what continuity assumption says, that bundles which are nearer to one another should have closer number associated with it. And what it does, it puts all the bundle in a particular manner so that one dimensional number allocation is good enough even when our consumption set is multi-dimensional. So this is more of a mathematical requirement. In reality, it may be applicable, it may not be applicable. What we are saying is that if rationality assumptions are not satisfied, you cannot talk about that particular decision maker. But if continuity assumption is not satisfied, we can always talk about that decision maker, but we will have to go back to the first principle, because continuity gives us a very nice mathematical property. It helps us with rationality and continuity. What we can do, that even if our consumption set has infinite number of bundle in more than, they are present in more than one dimension, still we can order them in one dimension, and that is a very nice property. Our n dimensional problem gets reduced to a single dimensional problem. And so what we can do is very simple thing, that let us say that when we have, because closer bundle should get closer number, so everything has to be reduced in a single dimension. So if we take a bundle, let us say here this bundle is x. Now any bundle, this x divides the whole consumption space into three parts. We can say one part is this, let us say x naught. It means it has all the bundles that you prefer to x naught. Second part would be x naught. So here you have all the bundles over which x naught is preferred. And the third part is, you can say, all the bundles that you are indifferent to. So we can have, and this we are doing just with continuity. So we can do something of this sort. Let us say we can have, so this sort of thing. So let us say that wherever this locus is passing through, here you are indifferent between this bundle and x naught, or this bundle and x naught, or this bundle and x naught, and everywhere here you have bundles which are more preferred, and here you have a bundle where x naught is more preferred to. So this is the way you can have graphical representation. Okay. So what we are trying to do, we are trying to figure out basically all the bundles, when you, all those bundles when compared with x naught, you find them indifferent. So we are trying to figure out indifference curve, or we can say indifference zone, because here it is not just a curve, it is a zone. Okay. Now we can have more assumption to make it represented in better manner. One more thing is clear, that if all the bundles can be arranged in one dimension. So what I said, let us say x, y, z, w, k, a, b, this is the way we can give higher number, we can give slightly lower number, and we can keep on decreasing the number. These numbers are in a way meaningless, in the sense that let us say we have 10 here, 5 here, 4 here, 3 here. We cannot say x is twice as good as y, that is meaningless. The only thing we can say, that here you have a higher number than 5, then x is preferred to y. So this is just like order. Let me give you another example of this order, that there is a race and someone has finished in 9 seconds, someone 100-meter race, someone has finished in 9.5 second, 10 second, 11 second, 12 second, and let us say 9.3 seconds. So we will say this person is first, this person is second, and this person is third. Can we say, can we compare the difference between second and third? No. even if this person has finished in 9.1 second, it would have been second. Even in fact 9.01 second, he would have been second, and 9.5 second would have been third. So it's just a comparison, it's just the order. What we are getting is an order, but nothing more. And this order can be associated to number. So rather than talking in terms of bundles, each time looking at the all comparison, we can simply look at the associated number, and we can compare the bundle. So what we are doing, we are assigning a number to each bundle. So we can say utility function, we can have u x is greater than or equal to u of y. Of course, we are taking two bundles. So for x, the number associated is u of x, and for y, the number associated is u of y. Ux, this number is at least as large as this number if and only if x is at least as good as y. So from preference relation, we move to numbers, and which are much more easier to deal with, and that is where when we have continuous preference, we can come up with utility function. I do not want to get into the theory, but the idea is very simple, that if rationality assumptions and continuity are satisfied, then preference relation can have utility representation. So that is very nice property to have, that makes problem shift from set theoretic to algebraic in nature. So that is very, very helpful. So we will always take help of this. Another thing that we should understand, that here we are taking u of x and u of y. Think of a, you use rubber to tie your hair or tie a packet. Take that rubber in your hand and cut it at one place mentally, and then you can put it like this, like a string. What you can do, that different utility numbers can be written. You can stretch it further. Once you stretch it further, the order is not going to change. So if u is representing the utility, any monotonic transformation that preserves the order, so we can do g of u, where g dash is greater than 0 everywhere. G of u x will also have g of u y exactly the same representation. So here life is very simple, that any monotonic transformation can also give you same preference relation. So what we saw, that utility representation is not unique. It is only unique up to its monotonic transformation. Okay. So, but anyway, it is very, very helpful in the sense of using mathematics and calculus. On bundles we cannot use calculus, but here we can use calculus as we are comparing numbers. So this is the primary discussion on preference. In further video, we will talk about some more assumptions. Thank you.